In this video, I'm going to show you how to evaluate these six integrals. These integrals are the first six problems in the 2019 MIT Integration B qualifying exam. Let's get started. If you look at this first integral here, if you know your trigonometric functions well, then you can already determine the value of this integral, and that is equal to 0, because tangent is an add function and its period is equal to pi, and the value of cosine x from 0 to pi and from pi to 2 pi are actually the same but opposite in sign. So you know that it will cancel out. Integral from 0 to pi and then integral of from pi to 2 pi will be the same but of opposite signs. So when you add them, it's equal to 0. So, but let us show that this integral is indeed equal to 0. So first, let's divide it into two integrals. So integral from 0 to pi of tangent of cosine x dx, and then plus integral from pi to 2 pi of tangent of cosine x dx. Now, I'm going to write this second integral. Okay, so let's make a substitution here. So we let this x here to be equal to u plus pi, because with this substitution, if we let x to be equal to u plus pi, then the limits of integration will be from 0 to pi. So in this case, x equal to pi means mu is equal to 0, and then x equal to 2 pi means u is equal to pi. And then that is tangent of cosine of u plus pi dx. And if you know the sum identity for cosine, this is just equal to cosine of u, and then times cosine of pi is -1, and then minus sine of u times sine of pi, which is equal to 0. So therefore, this is just equal to integral from 0 to pi tangent of negative cosine u. And then dx is just equal to du. So from here, you'll get dx, which is equal to du. And since tangent is an add function, so this is an add function. So therefore, tangent of negative theta is equal to negative tangent theta. So this is equal to negative integral from 0 to pi of tangent of cosine u du. But if we look at these two integrals, they are actually the same. They have the same value. So when we subtract them, we get a value which is equal to 0. So the value of this first integral is equal to 0. Now let's move to the second integral. If we look at this second integral, so the rule of the thumb before you try other integration techniques, try to do integration by u substitution first. And if we look at this integrand here, the only possible u here are this one, but it doesn't make this less complicated. Of course, we can have this denominator as our u, but we cannot produce the du. So the last thing that you could think of as your u is this one, which is x plus ln x. And if we're going to consider that as our u, okay, u is equal to x plus ln x, then our du is just equal to 1 plus 1 over x. And we can combine this into a single fraction, x plus 1 all over x, which is actually this one here, okay? X plus 1 over x. So actually, this is our derivative of u with respect to x. So therefore, it is clear that our du is equal to x plus 1 all over x dx. So we can, by substitution, we can actually write this integral as integral of du over u. And it's very simple. So this is just ln of absolute value of u and then plus arbitrary constant c, which is equal to ln of absolute value of x plus ln x, and then plus c. Next problem. So if we look at this third integral here, again, let's try substitution here. If we plan to use substitution, then this is a possible u, but the problem here, our du will be 1 plus e to the x dx, and it's not a factor of the integrand in this case. So also, if we let this to be our u, we cannot reduce the du. Now, it is helpful sometimes that you do some algebraic manipulation before you do u substitution. And in this case, there is actually a common factor between these two terms here, these two, and that common factor is actually e to the x. So we can factor that out, and we can write this one here as integral of e raised to x, and then plus e raised to negative e raised to x, and then times e to the x dx. So this is just the rule on exponents. If you multiply this by this, you add the powers e to the x plus x. So if you multiply that by this, you just add the powers and you'll get x minus e to the x. Now, with this new expression, as you can see, if we let this power of e, of course, if we're thinking of using u substitution and we have an expression e, then the best choice for u is the power of e. In this case, it's e to the x. So we can let that to be our u. And if u is equal to e to the x, our du is just itself times dx. So therefore, we can write this integral as integral of e to the u, and then plus e to the negative u, and then du. So this e to the x dx is just equal to du, which is a very simple integral. And this is just e to the u and then minus e to the negative u plus c. But of course, don't forget to put back the u in terms of x. So this is equal to e to the x and then minus e to the negative e to the x plus c. Now let's move to integral of 4. So here we have integral from negative 1 half to 1 half dx over 1 minus x squared. I think this is a very simple integral if you know your integration formulas, because we already have a formula for integral of what? Dx over x squared minus a squared, which is equal to what? 1 over 2a, and then ln of absolute value of x minus a all over x plus a, and then of course plus arbitrary constant c. So you can already use this formula here if you know this formula. And by the way, for me to easily evaluate this definite integral, then I can also use the fact that this function here, 1 over 1 minus x squared, is an even function. So the function value at negative x is the same thing as function value at x. And in that case, if it is an even function, then this is just equal to what? 2 times the integral from 0 to 1 half. And then dx over 1 minus x squared. Okay. But of course, this is not necessary. So you can just have the limits of integration, negative 1 half to 1 half. Now, if we want to use this integration formula, then we need to write this down as negative 2 integral from 0 to 1 half, and then dx over x squared minus 1. So we factor out the negative sign in the denominator. And in this case, using the formula, you can write this down as negative 2. You have here times 1. Our a is actually 1. So 1 is just the square of 1. So that is 1 half. And then ln of absolute value of x minus a. So that is x minus 1 all over x plus a, x plus 1, evaluated from 0 to 1 half. So this is just 1 here. So we can cancel that one. So this is equal to, you have here negative ln of absolute value of 1 half minus 1. So that is negative 1 half all over 1 half plus 1. So that is 3 halves. And then minus the value of this when x is equal to 0. So when this is equal to 0, it's ln of absolute value of negative 1 over 1. So that is ln of 1, which is equal to 0. So this is just minus 0. So this is equal to, you can cancel the 2 here. Okay, so ln of absolute value of negative 1/3, but that is just ln of 1/3. And if you're going to use property of ln, so this is just negative ln of 1/3, which is equal to, using property of ln, it's ln of 1/3 raised to negative 1. So that is equal to ln of 3. Now, what if you don't know this integration formula? Then you can also solve this by integration by parts. So if you, not integration by parts, you can solve it by partial fractions. So partial fractions, you have here integral of, let's say, 1 over x squared minus 1 dx. And this is just equal to integral of, in this case, 1 over, we factor out the denominator. So we're going to solve this by partial fraction, x minus 1 and then x plus 1 and then dx. And using partial fraction decomposition, so we may write this down as an integral of, you have here a over x minus 1 and then plus some constant b over x plus 1 dx. And to find this a and b, so the fastest way is using a cover up technique. So you can just find a to be the value of this one here. You cover the x minus 1 in the denominator, and you'll get here, it's the value of 1 over x plus 1 at x equals 1. So this is using a cover up technique, which is equal to 1 half. And your b here, so if you're looking for b, you cover this part here, x plus 1, and you find the value of this when this is equal to 0. So that is when x is equal to negative 1. So you'll get here 1 over x minus 1, find its value when x plus 1 is 0. So that is when x is negative 1. And you'll get here negative 1 half. So that's how you get the values of a and b, and you plug it here. Okay. But again, that will give you, so this part here is equal to integral of 1 half over x minus 1 and then plus negative 1 half all over x plus 1 and then dx, which is actually the same thing as 1 half of ln of absolute value of x minus 1 all over x plus 1 and then plus c. So I already used here a property of ln because this will give you 1 half ln of absolute value of x minus 1 minus 1 half of ln absolute value of x plus 1. And you can combine that into a single ln. You'll get ln of absolute value of x minus 1 all over x plus 1. So you'll get the exact same thing, which is equal to ln 3. Moving to the last two problems here. If you look at this one, integral from 0 to 2 raised to ln x dx. Note that this is an improper integral because ln x is not continuous from the right at 0. So this is an improper integral, and to evaluate it, we have to write it first as limit. So this is equal to limit as t approaches 0 from the right of the integral from t to 2, and then 2 raised to ln x dx. Now, this function here is already continuous on the closed interval 2 raised to t. So we may use fundamental theorem of calculus, second fundamental theorem of calculus, to evaluate this one. And the trick here to easily evaluate this is the fact that if you know this one, a raised to ln b is just equal to b raised to ln a. And I think it's very easy to verify this identity. If you take ln of both sides, then you'll get ln a times ln b is equal to ln a times ln b. So if we're going to use that trick, and this trick is actually true for any a b greater than 0. So if we use that one, we can write this one as limit as t goes to 0 from the right of the integral from t to 2 of, you have here x raised to ln 2 dx. And since ln2 is a number that is not equal to -1, we can just use ordinary power rule to evaluate that integral. So we have here 0 from the right, you have here add 1 to the power. So you have here 1 plus ln2 all over the new power, 1 plus ln2, evaluated from t to 2. And this is equal to limit as t approaches 0 from the right of, you have here 2 raised to 1 plus ln2 all over 1 plus ln2, and then minus t raised to 1 plus ln2 all over 1 plus ln2. But as t approaches 0, this approaches 0. So therefore, this is just equal to 2 raised to 1 plus ln2 all over 1 plus ln2. So here, problem number 6, we have this one, integral of this product here. It looks very complicated, but let's try to do FOIL expansion first. So this is equal to integral from negative 2 pi to 2 pi. So that is FOIL method, negative cosine 3x sine of 2019x. And then we have here cosine 3x times cosine 3x. So that is cosine squared of 3x. And then we have here minus sine 2x and then sine of 2019x. And then plus, you have here sine 2x and then cosine of 3x and then dx. And then now, if you look at this function here, okay, cosine is an even function, and then sine is an odd function. So if we take their product, okay, we get an odd function. So this is an odd function. Okay, so it is an odd function, so the integral from negative a to a of an odd function is just equal to 0. Also, if we look at this one here, again, sine is an odd function, so sine 2x is also an odd function, and cosine 3x is an even function. So if you take their product, you'll get an odd function. So this is also an odd function. Function value at negative x is the same thing as what? Same thing as negative of the function value at x. So if you have an odd function, you satisfy this equation here. It's negative of f of x. So that is a definition of odd function. And if you have an odd function, integral from negative a to a of an odd function is equal to 0. Now, this cosine squared 3x here is an even function. Also, you have here sine 2x, it's an add function, and then sine of 2019x is also an add function. Their product is an even function. So here we have another even function. If you're integrating, let's say, integral from negative a to a of f of x dx, and you know that f is even, then you can just write that down as 2 times integral from 0 to a of the even function dx. And I want to do this to make the computation a little bit faster. So I can write this down here as 2 integral from 0 to 2 pi instead of negative 2 pi to 2 pi. And we have here cosine squared 3x and then minus sine 2x sine of 2019x and then dx. I think you can already evaluate this one if you know your identities. So for example, for this first expression here, we have to use half angle identity, and we can write this down as 1 plus cosine of 6x all over 2. So that is our identity for cosine squared 3x. Now for this second one here, so we need to recall the product to sum or difference identities for sine, okay? And if we recall that one, we know that sine A sine B is actually equal to half of cosine of the difference and then minus cosine of the sum. You have that one. So if we use this identity, we'll be able to write this one here as you have this, let me write it in a different line here. So we can write this down as 2 integral from 0 to 2 pi of, you have here 1 half plus 1 half cosine 6x. And then minus, you have here 1 half of the cosine of, you have here cosine of the difference, that is negative 2017x, and then minus cosine of the sum, so that is cosine of 2021x, and then that is dx, okay, times dx. But since cosine is an even function, this cosine of negative 2017x here, again, we can replace here the difference, this minus here, by a sum. So it doesn't matter, okay, because cosine is an even function. So cosine of negative theta is the same thing as cosine of theta. And evaluating this one here, we'll get here integral of 1 half is 1 half x. So this is 2 times 1 half x, and then plus you have here 1 half integral of cosine 6x, that is just 1 over 6 sine of 6x, and then minus 1 half, and then times integral of cosine of 2017x, so you have here 1 over 2017, and then times sine of 2017x, and then minus 1 over 2021 sine of 2021x. And then everything evaluated from 0 to 2 pi. And this is equal to 2 times, you have here 1 half times 2 pi, so that is pi, and then plus sine of 6 times 2 pi, it's a multiple of pi. So sine of a multiple of pi will be 0. This will be 0, this will be 0, this will be 0. So everything will be plus 0. Okay. And then you have here minus, okay, 2 times when x is equal to 0, this is 0 again, sine of 0 is 0, 0, 0. So that is just 2 times 0. So therefore, this is just equal to 2 pi.